let's review the differences between solids, liquids, and gases. So we're familiar with water in all three physical states. In the gas state, we call it steam. The liquid state, we call water. And the solid state, we call ice. If you look at the densities here, we see that the density of ice and of water are similar, 0.9 something. The density of steam is much lower. And if you compare molar volume, the volume of 1 mole of this stuff at the same temperature and pressure, we see that the molar volume of the gas is significantly larger than the liquid and the solid, which are both similar. Not the same, but they're similar. And then we look at these illustrations, we see that in the solid and the liquid state, the molecules are touchingly close. They're actually in contact with each other. And in the gas state, there's a great deal of distance between the particles. In fact, if this was drawn to scale, if that was the size of a molecule and we were looking at this size of a box, there would only be part of a molecule in there. That's how much space there is between them. So I just told you, pointed out some similarities between solids and liquids. The big difference is freedom of movement. In the solid state, the particles are fixed relative to each other. In a liquid state, they have enough energy to partially overcome the intermolecular forces, the stick-togetherness, and slide around relative to each other. The particles in solids are moving, but they're just vibrating in position. So this summarizes density, shape, and volume for the three states of matter. We've already gone over the density. For shape, gases and liquids have indefinite shape. They'll take on the shape of their container. A solid has whatever shape it has, and it's just going to stay that way. You take an ice cube and you put it in a cup and you dump it into a bowl or you set it on the counter, its shape stays the same. You do that with water, though, and it spreads out. Volume, gases have indefinite volume. They will expand to fill the container. Liquids and solids both have definite volume. Their volume doesn't depend on the container. And then we have relative intermolecular strength. Gases have weak, liquids are moderate, and solids have stronger intermolecular forces. Liquids assume the shapes of their containers. We're familiar with that. Gases are compressible. Liquids and solids generally are not compressible. So here we have a liquid in a piston, and you can put pressure on that, and there's no room to squeeze these any closer together. They are already touchingly close. At most, you could compress it a very small amount. But you take a gas, there's a lot of empty space. And that empty space is not air. It is nothing. Those little green things are the air. And air can be compressed. So you put pressure on it and it will get smaller. Any questions? This is how the hydraulic brakes in your car work. There's a long tube filled with brake fluid, and you put your foot on the pedal, and that puts pressure on one end of the tube of liquid. And the liquid moves and transfers that pressure to the other end where it applies the brakes to your wheels. If you've got gas bubbles, air bubbles in your brake fluid, you need to get those out. It's called bleeding, because the gas, the air, is compressible. And so that gives you the soft brakes where you put your foot on the brake and not much happens because all that force is going into compressing the air instead of transferring it to your brakes.
That's how aerosols work too? You've got the liquid in there, but the gas?
Forming an aerosol is a different process than this. And I'm not prepared at this moment to explain it to you. I'll have to look that up. Two broad categories of solids are crystalline solids and amorphous. Crystalline solids have a regular repeating pattern. These things are nicely ordered. In an amorphous solid, they're just kind of all jumbled together. There's no long-range order. So this is like, sixth graders sitting nicely in their seats. They're all nicely ordered, and this is like the kindergartners sitting around the teacher on the floor at story time, they just sit down anywhere, right? All messed up. Amorphous means without shape. We're familiar with changes of state. We see ice melting, and we see steam when we boil water. So we're very familiar with heat changes or temperature changes causing state changes. You take ice and you heat it up, it melts. You take liquid water and you cool it down and it freezes. You can heat a liquid and cause it to go into the gas state. You can cool the gas and cause it to go into the liquid state. We did this part when we measured the molar mass of the volatile gas, volatile liquid. We took a liquid, we heated it up until it was all gas, and then we cooled it down and we got some liquid back. And it seemed like it just came out of nowhere, right? Because it all disappeared. We couldn't see it, but then when it condensed, we could see it again. Changes in pressure can also cause transitions between states. Let's talk about propane. So LP gas is liquefied petroleum gas. It's mostly propane. So here's a propane cylinder like you might have for your backyard barbecue. It contains liquefied petroleum. It's naturally in the gas state, but if you put it under enough pressure, you squeeze it together hard enough, you can cause it to condense into a liquid. Above the liquid, there will be some propane in the gas state. When you open the valve to light the grill, that releases this gas. The propane in the gas state will leave, and then some of this liquid will evaporate to replace what is left. So a change in pressure can cause a change in the state.